Hello everyone, my name is Austin Rovinsky, and I'm an assistant professor at New York University. This is the 5th lecture in my mini course on physical design databases, and this lecture will focus on introducing you to OpenDB. So at long last, we are finally looking at the database. First, OpenDB is structured as a hierarchical database, so there's just one single top-level object, and everything else in the database is ultimately linked back to that object. The class which represents this object is the DB database class. From there are 3 main objects you can access. First is the set of libraries loaded. When you load a Liberty file, this is where all of that logical information for the master goes. This is also where the physical information for the masters go if you read in the macro left file. Second is the set of technologies loaded. This is where the information from the technology left file gets stored when it's loaded into OpenDB. Remember that the tech left stores the technology rules for the process, like how wide can a wire be, or what is the minimum space between 2 wires. Then third is the DB chip, which is the container object for everything related to the design. Unfortunately, for most legacy reasons, the DB chip class doesn't really do anything except for pointing to the next object, which is the DB block. This block, as we discussed in lecture 2, is the top level structure for your design. Think of it like the top level of your Verilog plus all of the physical information that goes with it. So this is where the def file gets loaded in when you load that file. One thing to note is that multiple libraries can be loaded. And this is quite common actually if you, for example, have one library for your core masters, like logic gates, and one for your I/O masters, or masters which are used to drive and receive signals from off-chip. There are many other reasons to have multiple libraries, but those are just a couple. Similarly, you can also have multiple technologies loaded. This is actually much less common because you typically only see this if you're using multiple manufacturing processes at the same time for the same design. Vast majority of today's products only use one process, but this could change in the future. So looking inside of the libraries, the dblib structure, the main thing that is going to be included here is a set of masters. There's, of course, other information that can be included here, but the important thing is the masters. Inside those DB masters is going to be all of the information that we talked about in the sort of circuit taxonomy and what was stored in the Liberty files and the macro left files. So this will be a lot of physical properties like the origin, the width, the height of the cell type, the left cell type, the symmetry information, and then it's also going to have 2 vectors that are stored in there, the M terms as well as obstructions. So the obstructions are going to be the places within your master or any instance of it that you're not supposed to route to cover up the parts of the cell, the parts of the master that you don't want to route through. And then the M terms are going to be the terminals for this master. So before, when we were talking about circuit taxonomy, we may not have talked specifically about M terms, but we did talk about B terms, we talked about I terms. This is just the same designation. So these are terminals specifically of masters. And so when we look inside of that, we can see that there is a signal type, we can see that there's an I/O type. So signal type, usually it's going to be a digital signal. It doesn't always necessarily have to be. In the left standard, you can have other signal types, so we need to accommodate that. And then the I/O type is going to be input or output usually, but it could also be in-out, for example, as we mentioned in previous lecture. Then there's also going to be the shapes of the M term. The most important part of this is going to be the vector of M pins. So this M term is going to be the logical part, and then the physical implementation of that is going to be in the M pins. And inside of those M pins is just going to be the shape information, the geometry, where are those rectangles. This is a vector because there could be multiple different pins. For example, if you want to make available connections on metal layer 2 as well as metal layer 3, you could have two different M pins to say that both of these are valid physical connection points to this logical terminal. So stepping back down from the libraries, we're going to look at instead the DB block. So inside of the DB block is going to be, for the most part, B terms and instances, at least the parts that we're looking at this lecture. Do note that there is a lot of information that's stored in the DB block, and we'll cover some parts of that, but you may have to just spend some time exploring it on your own if there are parts that you need to use that aren't covered in this lecture series. But to start with, looking at the DB B terms, which is going to be a vector of all of the different block terms that form your design. So this is going to be all of the inputs and all of the outputs, the logical terminals. And within each of those, it's going to have some information such as what signal type it is, the I/O type, and so on, some more information. So it's very similar to what we saw for the M terms. But within each of those is going to again be a vector of B pins, block pins, which are the physical implementations of those. Next, we look at the instances of the design. So there's a very large vector of DB insts, which is the class for storing the instance information. And inside of a DB inst, we'll see that there's information like the origin, the orientation, what is the placement status, and placement status we can cover a little bit later on, but it might be things like, is this cell unplaced, meaning it doesn't have a set of coordinates yet, or it might be placed, but you're still allowed to move it, so it has coordinates, but maybe the tools are allowed to shift them around. Or it could be fixed, meaning that it's placed in this location, it should not be moved anymore. Last, we have the I terms, which, contrary to what you've seen for the other terms, actually doesn't have very much information in it. So the point of having a distinction between M terms and I terms is that M term is going to be only one sort of master copy of that data. There's no need to replicate that commonality between all of the instances multiple different times. So here in this DBI term, we normally just have a pointer back to what is the master, what is the information stored there, and then we only need the different information, sort of what's different between each instance stored in this DBI term. And so the main difference that's going to be between the master and the I term is that this is going to be connected directly to a net. So every instance of a master will be connected to a different set of nets. And so this DB net pointer is going to distinguish exactly which net it's connected to. So that is sort of a first look at what is the structure of OpenDB. In summary, it's a hierarchical database, so it starts from one top-level object, the DB database, and then works down from there. And then we covered information related to libraries and chips, was sort of the design information that's stored. And we sort of covered just the surface level of where are the technologies stored, but we'll cover a little bit more details on that next time. That's all for this lecture. I'd like to take a moment to thank NordTech, who provided the funding to make this mini course possible, and I'd like to thank you for taking the time to watch it. I'll see you next time.